All right, let's take a look at an example of how this might be done. So we have a situation where a ball is moving at a certain speed, and we have this force function that is described by a graph, and we're asked to find the initial speed. Now go ahead and pause the video if you need to jot this down into your notes if that is helpful. So the guiding principle is that the momentum that we start with plus the impulse that we're going to find using the graph tells us the final momentum. And of course, momentum is calculated by looking at m times v. What we are going to then do is use the area of our graph to determine j. So j will be the area. And let's just kind of notice something about this graph. So you've got a positive section and a negative section. This area here is going to be identical to this area here. So they will cancel each other out within our calculation. The impulse gained in that first 0.2 seconds is later lost in a later section. And then we have this other part here where we have a triangle. Okay, so I'm going to kind of divide this up and notice that again I can sort of cancel out the positives and negatives. So really all I need to do is to figure out the area of that little leftover triangle. So that would be 1/2 times the base, which is 0.2 seconds, times the height, which is 12 newtons. Again, officially it's negative. You could put a negative sign in here with the force if you'd like. However you want to do it to make sure that the j comes out negative. But this comes out to be negative 1.2 newton seconds. And so putting that back into our formula up here, we would say that the initial momentum, which is 0.05 kilograms, that's a 5, times 40 meters per second, minus this 1.2, that's the impulse j, that determines the mass times the new velocity. And this comes out to be 16 meters per second. Makes sense that it's lower than the original amount.